All right, here are how to calculate mixed stoichiometry equations, where here our given and unknown are going to be in different units. So if you haven't seen any of the other videos with like mass, volume, or particle problems, I would go back and check the YouTube channel for those because those are going to give you the foundations for kind of mixing these all together. All right, but in general, what we want to do is we want to convert our given to moles because in stoichiometry, we always use the molar reaction ratio. This is from the balanced equation. This is for every single problem that we do in stoichiometry. And then at the very end, we need to convert our unknown into the units that we wanted. All right, so if we review our mole roadmap, the unit that is central to everything in the center of our map is going to be the mole. So we might be in grams trying to convert to moles, or we might be in liters trying to convert to moles, or we might be in molecules, atoms, or formula units trying to convert to moles. But in essence, we need to get from our given into moles, then from the moles of our given to our unknown, and then back out again. So it's going to depend. We might use one of or two of any of these. All right, and this mole roadmap kind of tells you that we could have different possible mixed problems. Okay, you can have a mass volume problem, you can have a mass particle problem, where the first part is like a mass problem, the second part is like a volume. First part's mass, second part's particle. You can have a volume mass problem, you could have a volume particle problem, or you could have a particle mass problem, or you could have a particle volume problem. Okay, but the good part about learning this type of reaction calculation is that you can use this for any of them. Okay, you can use this for any of the stoichiometry calculations because the game plan is very general. You first start with your given unit. Whatever that unit is, you use some part of the mole roadmap to convert between the units of your given into moles of your given. That's what this step does. It will always be 1 mole over some part of the mole roadmap. Then, like in all stoichiometry problems, the recipe portion is going to be that balanced equation that we used in order to figure out what our reaction ratio is. This will be the moles of your given converted into the moles of your unknown. And then lastly, we are going to use some other part of the mole roadmap. Maybe it's the same part, but you're going to use that mole roadmap conversion over 1 mole of your unknown in order to convert into the desired unit that you want. Okay, so here is an example of this. We have our same equation that we've seen in our other videos. So first, let's make sure that we balance this out. We have 1 and 2. You don't need to put the 1, but it's implied. For every 3H2 gives us 2 NH3s. And here, our question word, what volume of ammonia at STP, little hint there, is produced if 25 grams of nitrogen is reacted with excess hydrogen. Excess hydrogen is just saying that we have more than enough of it, okay? And whenever you do a recipe in the kitchen, you're going to have both of those starting ingredients, so we might as well say that. All right, so we are looking for what volume, come on, what volume or liters of NH3 is our unknown, okay, at STP is used if 25 grams of nitrogen are started off with and given. Okay, so we obviously are going to have a gram liter problem. So this means that this is a mass volume mixed stoichiometry equation. Okay, so that means the first part's going to look like the mass videos that we did, and the second part is going to look like the volume videos that we did. But we will always, always, always be using the mole conversion reaction ratios from our balanced equation. So the reaction ratio is 1 mole of N2. That's my recipe, that's what it says, for every 2 moles of NH3. So how do I convert in a mass problem? How do I get from grams of N2 into moles of N2? Well, we're going to have to do a side calculation. Do you have your best friend periodic tables? Bring them out, bring them out. All right, so the molar mass of N2 is going to be 2 times 14.01 grams per mole, or 28.02 grams of N2. That's how much 1 mole weighs. That's going to be my first conversion factor. Okay, what is my other conversion factor? How do I get from moles of NH3 into liters of NH3? Do you remember the hint? STP. This is where we're going to use the molar volume. 1 mole is going to occupy 22.4 liters. So that's what we're going to use there. Okay, so let's write out our game plan. All right, on the previous slide, we said that we would have a given unit times some part of the mole roadmap times our reaction ratio times some other part of the mole roadmap. So what we're going to do here is kind of specify what we're going to use. Okay, so our given unit is going to be a given mass. Then what part of the mole roadmap changes mass into moles? That is the molar mass of our given. Then we use the reaction ratio, that doesn't change. And then what part of the mole roadmap changes our moles of our unknown into liters? That is the molar volume. So that is going to be that STP conversion of 22.4 liters. All right, so we're going to plug into that and see how that all works out. Okay, so first, our given 25 grams of N2. Then make sure that you have your 3 conversions multiplied out and ready to go. If I want to get rid of grams, I put grams of N2 on the bottom, and I looked it up. It is 28.02 grams of N2. And now that cancels out grams of N2. Next, we end up using the reaction ratio, which is 1 mole of N2 for every 2 moles of NH3. That's what my balanced equation up here tells me. That's my recipe. If I have moles of N2 here, I put 1 mole of the given on the bottom, and I put 2 moles of NH3 up top. Moles of N2 and moles of N2 cancel out. And then lastly, I need to use the molar volume, which is 1 mole equals 22.4 liters. 1 mole of NH3 goes on the bottom, so moles cancel out, and 22.4 liters of NH3 go up top. Moles and moles cancel out. Okay, go grab your calculator if you don't have it. All right, in your calculator, you multiply everything on the top, divide by everything on the bottom, push pause if you need to go grab your calculator. Don't just watch me plug it in. Make sure that you are taking the time to put it in the calculator to see if you get the right answer. So push pause as you need in the video. 25 times 2 times 22.4 divided by 28.02 divided by 1 is the same, and we end up getting 40 liters of NH3. That is our answers. This has 2 sig figs. If I put my decimal point right here, my answer has 2 sig figs. All right, so let's take a look at our problem again, a second view. Again, for the mixed equations, you're going to plug in what part of our mass, or volume, or particle problems that we have done in previous videos. All right, so since this is a mass volume problem, the mass part is here, the volume part is here, and we always use our reaction ratio in stoichiometry. Okay, that happens no matter what. So if we start with mass, here we have our grams of N2. Here's our grams of N2 on the bottom from the periodic table. Remember, we get that from the periodic table. And then we put 1 mole of N2 up top. Then we have 1 mole of N2 canceling out with 1 mole of N2 from the reaction ratio, and 2 moles of NH3 from that balanced reaction ratio. And then we cancel out moles of NH3 with moles of NH3 and our molar volume right here. Okay, and then our answer plugged in is 40.0 liters of NH3. Now, pro tips, things for you to remember. You will always start with your given unit here. Okay, whatever part of the mole roadmap you need in order to convert it goes on the bottom. 1 mole in your numerator of your given up top. You'll notice it's always 1 mole up here. Then you have your moles of your given from your balanced equation on the bottom, your moles of your unknown up top, and then 1 mole of your unknown on the bottom, and your part of your molar roadmap of your unknown in the numerator. Okay, so that is a mixed equation. I hope you guys enjoyed it and are able to plug into the general game plan and solve your stoichiometry.